Greetings. I was talking to Aaron Patterson, and I asked him if he intended the pun with his language, Tinderlang, a pun on Erlang in there. And he said it was a missed opportunity, so I think I would go ahead and seize that opportunity just now. Laughter, please. Anyway, this is OsaGaius. I hope I pronounced that right. Really interested in this talk, Genealogy of Functional Programming. So please, Osa, tell us why Elixir matters.
Hi there. My name is OsaGaius, and today we'll be talking about why Elixir matters, or put differently, how to make Elixir matter. Moreover, I plan to provide today a genealogy of functional programming. I work at MailChimp in Atlanta, Georgia. MailChimp is the world's leading marketing automation platform for small businesses. In addition, I organize the Atlanta Elixir Meetup, and I've done so for almost 2 years now. An interesting event happened recently. We live streamed the event, and Chris McCord came in and watched it, and the entire crowd there was really happy. So it's good to be here at Lonestar Elixir. This talk will proceed as follows. First, we'll have an introduction. Following that, we'll discuss what I mean by genealogy. Then we'll explore the history of functional programming before, of course, discussing why Elixir matters. We'll then wrap up with some thoughts on how exactly we can move forward. A few months ago, a young man walked up to me after one of the Elixir meetups, and he asked me a very interesting and simple question. Why should I learn Elixir? As I began to talk through the features of the language, I paused. I realized that I knew nothing about him. And I sort of asked him, I said, what's your name? And I began to ask him some questions about his background, how he got around to coming to the meetup. He'd been there a few times, so I was interested in knowing why he was coming. And so he started explaining to me that he was part of this full-time programming boot camp at General Assembly where he was learning how to write code. And his question really was, why does functional programming matter? You see, he was learning Node.js and Ruby on Rails, React.js, AngularJS, all of these things in 12 weeks, right? It was crammed in there because the purpose was to get a job after he was done. On the nights when he wasn't working his regular job, right, as a bartender, he was coming to meetups like mine to learn more about programming so he could get a better job when he graduated. He was trying to soak up more knowledge. As I looked in his eyes, I realized how tired he was. I could see the bags forming under his eyes. But I also realized that his question was a little more nuanced. His question was, why should I spend the limited amount of time I have outside of my programming boot camp, outside of my job, to learn this Elixir thing? Why should I spend my time learning functional programming? I wanted to admonish him, right, to understand concurrency, to understand like modern distributed systems. I wanted to tell him to go home and watch every Rich Hickey video that existed on YouTube. Because those lectures changed my life and they changed my perspective on programming. I wanted to tell him that indeed recursion was so beautiful and that it would change his life as well. But I realized at that point, going back to how tired he was, that he was just hoping, praying, that when he graduated boot camp in a few weeks, after paying $10,000 out of pocket, that he'd be able to find a job somewhere where he could be a junior developer and write some code and begin his career. I realized that my answers to him mostly were sort of very theoretical. I was fumbling through an introduction to distributed systems so that he could understand why processes matters and things of this nature. But instead I told him, focus on learning Rails, focus on learning React, because here in Atlanta, Georgia, that's how you're going to get a job as a programmer when you're done. I went home that night pretty sad and exhausted, tired after running the meetup, but also exhausted because I realized that in some ways I had failed. I had failed to explain to him why functional programming mattered in a way that was, succinct and clear and helped him understand how he could learn functional programming. As I reflected on why I had forgotten how to explain functional programming, I realized it's because I'd forgotten why I fell in love with it in the first place. You see, like many of you, I started my career writing some sort of functional code. Started out writing functional React on the front end, then moved on to writing a great deal of Clojure, and then finally settled on Elixir. So for me, I've always been doing functional programming. It's been part of my life for the last few years, speaking at conferences, etc. And so part of this is the reason why I was unable to provide a credible explanation to someone who had no background, no biases, and no mental models to talk about functional programming. A sizable portion of the folks who come to my Elixir meetups are exactly like this person. They're boot camp students, they're new to programming, they're trying to understand why functional programming matters to them. They attend the meetups because for them it's really, how do I get a job? How do I get in the industry? How do I progress my career? And a lecture on some functional abstract programming concepts like currying, etc., does not provide any utility for them. In fact, it confuses them even more. And so I realized at that point that my failure to defend Elixir was partially because I think I failed to understand how to explain it to folks who don't have the same background as me. So just as I failed to defend Elixir, a fundamental presupposition of this talk is that functional programming has in some ways failed. Which is to say that we as a functional programming community have failed. Failure, I suppose, stings. It hurts. It hurts to say we failed. Its very definition and declaration sort of like makes us cringe a little bit, especially at a functional programming conference. However, when we look at the top 15 programming languages over the last couple of years, last few decades, functional programming languages never rise to the top 10, not even the 15. Now, functional programming languages consistently become more popular, they continue to rise, and the challenge is we continue to observe that languages like Java, Python, and even Ruby continue to flourish and continue to rise, whereas functional languages sort of wane slowly over time. Even more alarmingly, if we define success as the availability of jobs, as we can see here, we come to the conclusion that functional languages have sort of missed the boat. As you can see here, in the last 2 years, functional languages do not offer the same number of jobs as even PHP or Perl. So how can we in good conscience, how can I in good conscience really tell my bootcamp students who are coming to these meetups that they should learn these functional languages? This is the question that I kept asking myself that night. Now, I'm aware that we can define success in other terms, as breaking ground in new research or inventing new styles of approaching programming. However, I think that approach to thinking about failure and success is dubious, because it avoids the hard work of addressing why functional languages continue to miss the boat. In fact, the prevailing argument of this talk rests on the claim that functional programming fails. We fail precisely because of our incapacity to be attuned to the realities of being a programmer, the reality of getting a job, the reality of having to go in and say, these are the skills I have, can I come work here? Our capacity to reverse the tide, to rise in terms of popularity, will be marked precisely by ability to understand these fine differences and to take into account why functional languages are not in that sort of top 10 list. So with that in mind, let's talk about genealogy. Genealogy is the method by which I plan to discuss the history of functional programming. In our case, I believe that most commentaries on programming languages, on their adoption, etc., fail to account for power or history as an element in these discussions. In other words, these commentaries on functional programming languages are sort of done in a vacuum. There's a tendency to focus on language features, for instance, static versus dynamic typing. While important, this fails to get to the heart of why certain languages fail and others become popular. Moreover, in the case of commentaries on functional programming, we fail to discuss why Erlang or Lisp failed to take hold. And instead, we get muddled in discussions about their features, like currying or pattern matching, and why these things are amazing and so beautiful. In an even worse turn of events, what we tend to do as a community is get sidetracked into discussions where we simply malign other languages to make fun of them. We make fun of Java, we make fun of Ruby, we make fun of the programmers who use those languages. Now, I'm not saying we're all guilty of that here, but it's definitely a tendency I think we tend to have. What these diatribes miss is a proper analysis of the past. I argue then that genealogy is the method that we should use to analyze the past and to analyze the history of functional programming. But of course, what is genealogy? Genealogy takes on two forms. First and foremost, it is an account of the history of a family or the ancestry. Genealogy allows us to understand a group of individuals and species that have a common origin. Put simply, your genealogy, for instance, is the story of you, your parents, your grandparents, your aunts, your uncles, etc. Secondarily, though, genealogy can be traced back to this man, Michel Foucault. Foucault is a French philosopher who thought of genealogy as an analysis of the development of ideas or truths through history. For Foucault, genealogy is gray. It is how we understand why some things take precedence over other things, why some things become popular and other things do not become popular. For instance, take the question, why did the JVM become more popular than the Erlang VM? In today's commentary, the messy details of power and knowledge are left unanswered. More alarmingly, the question often receives sort of a devolution into, people making fun of or poking at the Java syntax, or talking about why the Lisp syntax is better, or why Elixir syntax is better. Or we then begin to discuss why just-in-time compilation doesn't really matter, or why it's not as useful. However, these are sort of, conjectures. From a genealogical perspective, though, we must delve into the gray, into the politics of industry adoption, into the undocumented conversations and code bases. So here, I will treat functional programming as a family of languages with different species and perform a genealogy of these languages. And I think this will help us to better deconstruct our accepted precepts about the development and the adoption of functional programming. So with that in mind, let's talk about the history of functional programming. We'll look at functional programming from the 1930s to today, and then we'll glance a bit and kind of, talk a bit about what the future of functional programming could look like. So the first period that we'll look at, I define as sort of early work. The early period of functional programming begins in the early 1930s and lasts until the late 1960s. Lambda calculus emerges in the 1930s, led by Alonzo Church's work. It is a system of mathematical logic for describing computation based on functions, using variable binding and substitution. It is a model of computation that can be used to build something elaborate like a Turing machine. It becomes the common ancestor of all functional programming languages that we know today. In 1958, we see functional programming, which we can think of as this very interesting approach to lambda calculus, take some of these ideas around lambda calculus that are very, very challenging and attempt to make them real. First, in 1958, we see Lisp get invented by John McCarthy. Lisp was not truly based on lambda calculus, but instead simply used the word lambda to define and denote functions. It instead was based on first-order recursion equations with dynamic bindings and expressions. It is considered, though, the first application of functional programming design, and it then becomes the basis for a series of other languages. To borrow from C.K. Ewan's phrasing, Lisp is basically lambda calculus with a user-friendly appearance and syntactic sugar. The second period of functional programming begins with Scheme, and I define this period as sort of a pre-Renaissance, or the making of functional programming practical. Scheme emerges in 1970 and marks the beginning of this period. While still focused on academic research, we see an overall dedication to taking the early ideas from Lisp and lambda calculus and making them more useful for actual programming work. This period that we'll define here as the pre-Renaissance lasts until 2000s. Scheme is one of the main dialects of Lisp. To quote David Turner, the author of Sassel, it is not until that versions of Lisp, like Scheme, appear, it's not until Scheme that we actually see versions of Lisp appear that actually implement all of lambda calculus. Put simply, Lisp emerges, and then Scheme takes Lisp, and then makes sure that it actually adheres to lambda calculus. More interestingly, Scheme kind of becomes this sort of basis for a series of other languages. In sort of the most interesting case, it becomes integral to the development of Common Lisp, which becomes a more popular version of Lisp going forward. In 1973, we see the immersion of ML, which continues the process of building upon Lisp by adding static typing. It also introduces the novel concepts around pattern matching for function arguments. Pattern matching would therefore become a de facto standard for most functional languages. In 1986, Erlang emerges. And as you may know, it starts at Ericsson as an R&D project to create a language for telephone switches, but it's mostly interested in building a better language. Interestingly, Erlang, during the early phase of the project, attempts were made simply to modify Smalltalk or to use Prolog as sort of the basis for Erlang. Erlang is notable because it merges very strongly for the first time in the history of functional programming ideas around concurrent programming and functional programming. this sort of merging of these two subdisciplines becomes very entrenched in the rest of functional programming, such that we can't talk about functional programming today without also talking about concurrent programming. Erlang is also interesting because it's one of the sort of first times we see in the history of functional programming up to this point where a language is being built that isn't sort of strongly tied to Lisp in the same way as Scheme or ML. Miranda emerges next as a descendant of the ML language in 1986, or 1988 rather, and it popularizes ideas around laziness within the functional programming community. Haskell closely follows that in 1997 and borrows heavily from Miranda, especially those ideas around lazy evaluation that it introduced. However, it introduces or adds on to that static typing. The next period that we'll talk about is what I call the Renaissance of functional programming. Following the late 1990s, we see a resurgence of interest in functional programming in a period that I'm terming the Renaissance, but we could also call industry adoption. This period can be characterized by attempts to make functional programming useful within industry. Right? If you think of sort of the pre-Renaissance as being academic research to make functional programming more useful for programming work, now we see folks taking that academic work and making it useful for industry types of tasks. We see the development of languages being led not by university researchers or industry labs, but by industry practitioners. We see people building languages to solve their own problems, real problems, by compiling to other languages or to other frameworks. It begins in 2004 with Scala, a functional programming language that runs on the Java Virtual Machine, or JVM. Although object-oriented, it borrows heavily from Scheme, ML, and Haskell. We then see F#, a direct descendant of the ML family of languages, get introduced in 2005 by being built on a Microsoft.NET platform. In 2007, Clojure emerges as another functional programming language running on the JVM. It leverages the power of the JVM, but unlike Scala, it retains none of the object-oriented features of Java. It instead adopts Common Lisp almost wholeheartedly in terms of dialect, programming model, as well as syntax. In 2009, Akka emerges. Although not a functional language, Akka is important in the history of functional programming because it symbolizes this renewed interest in the intersection of functional and concurrent programming. This was an idea that, as we mentioned before, Erlang sort of opened up and made sort of core to the world of functional programming we know today, and has become even more important as web services continue to grow. We can think of projects like Microsoft Orleans or even Lisp as attempts to continue this intersection of functional programming as well as concurrent programming. In 2010, Rust arrives. It borrows heavily from Haskell's approach to typing with an emphasis on concurrency. And then, of course, Elixir emerges in 2011. It's an outgrowth of Joseva Lim's attempt to build a language that addresses some of the concurrency limitations within Ruby. It's built on and, of course, compiles to Erlang. Lastly, 2012 marks the rise of Elm, another part of the ML family of languages. It compiles to JavaScript and emphasizes strong typing. It is early evidence of the desire to take functional programming outside the context of building applications for servers and instead thinking about how to continue to do this on the front end. This trend continues with things like React, Redux, and even ClojureScript. Although Elm ends the period, the Renaissance we speak of, that we're looking at now, we'll rewind a bit and instead focus on Elixir and Erlang. Because in order to answer the question why Elixir matters, we of course have to answer the question why Erlang matters. I think that this quote by Joe Armstrong is quite apropos. This quote comes from part of his meditation in 2007 on the history of Erlang as part of the ACM series of conferences on the history of programming languages more generally. He says, "The rise in popularity of the internet and the need for non-interrupted availability of services has extended the class of problems that Erlang can solve. For one, it is true that the industry today is interested in building resilient web services that solve specific problems. This question perhaps then is, why then are we not seeing a rapid rise in the popularity of Erlang? Right? Why are we not seeing Erlang in the top 10 list, as Joe's sort of claim would have us either believe or hope for? Again, if we revisit that graph from earlier, we do not see Erlang in that top list. Cautionary though, we don't see Elixir in that list either, right? So this is not a diatribe about the failure of Erlang, right? But rather about how we can think about these things. I believe that there are three axes that we can think through as to why this is the case. I think the first is syntax. Just as Lisp is syntactic sugar on lambda calculus, we can make the argument that Elixir and Phoenix are web-focused syntactic sugaring on Erlang, right? Perhaps controversial because Elixir is a separate language on its own, and a crowning reason, though, for its value is its ability to take Erlang and represent it to a new generation. My argument then is that Erlang precisely misses an opportunity or fails to rise to that list because its syntax is, we could say, unfriendly, or we could say not approachable, but more simply, it doesn't look like the syntax that modern developers are used to using, right? Whereas languages like Java, C++, etc., are beating to you when you go to school, when you take your first job. They are already sort of entrenched in industry, and so languages like C# emerge and simply copy that pattern, whereas Erlang misses an opportunity there precisely because the syntax is so radically different. The second axis, I think, then, is the web. We missed an opportunity in the case of the Erlang community to help shape the web. Although technologies like RabbitMQ and eJabberD are built on Erlang, the language itself does not hold as a general purpose language for building web servers, right? It is that, but it does not become that in terms of popular industry adoption. If we trace its development, we see that Java, JavaScript, Ruby all emerge after Erlang. Erlang emerges in 1986, Java emerges in the early 1990s. We then see JavaScript emerge. Following that, Ruby emerges, and then last of all, we see Rails emerge in the late 2000s. And what we see all through this sort of pattern is that although Erlang beats everyone in terms of adoption early on, as time progresses, we see Erlang begin to wane outside the context of Ericsson. Now, when we can think about why this occurs and what it means for Elixir, I think that Elixir, by contrast, was built from the beginning with the web in mind, due to Jose's background in the Rails core team. He aimed to solve a problem that he had with regards to building web applications during this Renaissance period. The development of Phoenix and the emphasis on Rails-like simplicity with regards to web development is also characteristically different from what we saw in the early 1990s and the early 2000s in the case of Erlang. And for that reason, we have a particular opportunity. The last thing we'll discuss as an axis of why Elixir matters is context of evangelism. If we examine Java, JavaScript, Rails, and even a modern language like Go, we see an emphasis by companies and the stewarding organizations on promoting the language, marketing the language, if you will. The reality is that Ericsson did not emphasize this, at least not in the extent that, let's say, Sun Microsystems did in the case of Java, or Oracle did after that. In the case of JavaScript, Netscape and the Mozilla team were aggressive in promoting and ensuring the use of the language. It is also somewhat ironic that JavaScript was originally written as a mashup of Scheme, a functional programming language, and Java itself, which are both object-oriented. So we could think of JavaScript as sort of a post-functional language. So if we revisit Joe's quote, I'd argue then that it is more accurate to say that Elixir extends the class of problems that Erlang can solve in the age of internet services. But how do we, the Elixir community, ensure that this actually happens, right? Like, this is a hope, this is a dream. How do we ensure that Elixir and Erlang rise to that top tier of programming languages over the next decade? Moving forward. So this section, I think, is quite interesting, because on one hand, I wanted to end with Joe's quote and just say, well, we have this hope, we have this dream, let's go do it. But I thought maybe, let's present some practical things that we can do as a community, especially in the context of languages like Java and JavaScript. What can we look at in their past in terms of strategies they took to go from relatively unknown languages to becoming sort of very dominant languages in industry? So the first sort of step is to look at what the research says about language adoption more generally. Meyerowitz and Rabkin did a great sort of study of programming language adoption over the last couple of decades. And they sort of end with this great quote that unpopular languages are niche languages, right? And this is very great as a statement because I think the corollary is also true, which is that niche languages are by definition popular languages. So for us, what does that mean in the context of Elixir, right? It means that we must take into account breadth versus depth, right? One tendency of functional programming languages we see going from Lisp all the way to ML and Haskell is a tendency to, once we begin to develop the language, proceed even deeper into the functional programming, right? So we then begin to discuss things like monads and monadology, right? This is where things get a little crazy because we're interested not in the usage of the language, but more interested in like functional programming theory. And that's a tendency, right? A tendency we can see over the course of programming language adoption. And that's a thing. Someone's calling me. And so I think that's one challenge we have to be very careful of in the context of Elixir, is we can either go really deep with regards to functional programming and begin to implement all of the very interesting ideas from the functional programming research, or we can step a bit back and say, well, how can we sort of widen the base of people who are using the languages? And I think how we do that is a different approach. So with regards to breadth versus depth, in order for us to sort of get more breadth, I think the first is to consider libraries as sort of the first approach that we should take. In other words, how can we build useful tools for people on the language itself? If you think of the case of Ruby or Rails, you think of gems, right? This sort of thing we look back on. There's a gem for every problem. If there's a gem for that, right? We can sort of argue about whether or not that's the best approach to programming, whether we should use these libraries or we should not. But I think that approach of saying, well, I have a programming language. Now, what are the problems that people have that I can go help them solve, is a question of breadth versus depth. The second thing to think about from Meyer Horwich and Rapkin is the question of domains, right? In what domains can the programming language be used? So we think of domains both in terms of actual applications. So can this be used in telephony? Can this be used in building business services? Can this be used in all these sort of different domains? And then more interestingly, can these be used on hardware? Can this be used on the web server, on the front end? We see this kind of pattern in the context of Java in its early development, right? Being sort of a general purpose language that can be used for building web applets, can be used for building things on the front end, so to speak. And that approach that Java took and that JavaScript also copied with development of things like Node.js, et cetera, is sort of an approach I think Elixir ought to think about, right? How do we generalize the domains in which we can be used? I think the development of things like Nerves with Phoenix, et cetera, are examples of how we can continue to broaden the domains in which functional programming, particularly Elixir programming, can be utilized. However, I do think there's work to be done. I think it's important not to sort of congratulate ourselves too early because we have a series of libraries. I think a useful strategy or heuristic to say is every single thing that Java has in terms of support for industry applications, Elixir ought to have an answer to, right? Perhaps not an exact copy of the library, but we ought to have an answer to these questions because when people go to their boss and say, I want to use Elixir, the first question will be, is there a driver in Elixir for this thing? Is there a driver in Elixir for that thing? And that isn't particularly interesting academic or functional programming work, but it's the kind of work that will matter in terms of getting us from being a sort of niche community as we are today to being a community that's more generalized. Now, the second sort of part of work that needs to be done is evangelism. And I'm going to choose to spend a bit more time here because I think this is probably what's harder for us as programmers, especially people who love academic research, is to do evangelism. I think the first area of evangelism is marketing, right? I think you look at Java, you look at Sun Microsystems, you look at JavaScript in the case of Netscape, and then followed on by Mozilla. We see a heavy emphasis on marketing the languages. I mean, millions of dollars were spent on marketing ads all over the world for Java, right? Which is something that we think of as very strange because we're purists. We think like programming languages should just like bubble to the top because they're better. But the reality is like marketing is part of how programming languages have always and will always continue to become popular, right? Things like sponsoring conferences, things like taking out ads, things like going to conferences and evangelizing are part of how we actually get these languages to become adopted. The second, I think, is around consultation, right? I think this is interesting to see companies like Dockyard do this, right? To consult with people and say, here's a problem you have, and here's how Elixir and Phoenix can help you solve that. But I think we as a community have a lot more work to do with regards to this. I think there are a host of companies that are much larger enterprises that we can go to and say, what problems do you have, and how can we solve them? I think Erlang Solutions is also doing this work sort of intrinsic to who they are, but I think we as a community can do this even more by reaching out to companies that we work at or other folks work at and say, well, here's this Elixir thing. What problems do you have? And perhaps we can't solve them with Elixir, or perhaps you're not in a place to adopt them, but let's help you sketch out a plan. Let's help you look at how this might help you. This is work that might not be paid. This is work that probably you can't get paid for at this point, but it's work we need to do in order to actually help leapfrog the language and make sure adoption picks up the way we want it to. And the last thing I would say is around fanning out. I think fanning out is going to be a bit tough, right? You know, we're here as Elixir developers at Elixir Conference, but I would argue that we need to go to other conferences, right? Not just Ruby conferences where we have some love already, but we need to go to the Java conferences, the Clojure conferences, the conferences where people don't already know these ideas as true, where they don't already accept that functional programming is the way that the world should exist. We need to go to those conferences. We need to give talks at those conferences. We need to lurk and spread the word, because that's precisely how we get folks who aren't already in our ecosystem to begin to adopt these ideas. I think it begins with humility. It begins with saying, here's some ideas we think can help. But generally, I would say that ought to be a strategy. So if you're speaking at an Elixir conference, look around and find other conferences that are not Elixir related and attempt to go speak there. I've done this over the past year or so, gone to speak about Elixir at React conferences, gone to speak at conferences that are front-end focused. And what I find is that people find that these ideas around Elixir and functional programming are very helpful, because when they look at their front-end work, whether it's in React or Redux, these ideas are entrenched in the work they're doing, but they never had an explanation of why functional programming matters, or what functional programming means outside the context of the front end. So I think this is useful work that will help help people adopt the language, but I think it's work that's very hard and work that we ought to think about how we do. Now, by way of conclusion, I think that the history of functional programming is not static, and rather it's always already political, right? When you think of Java and JavaScript, we see that functional programming, is always sort of in the background precisely because we miss an opportunity to politicize ourselves, to promote ourselves, if you will. But we are responsible for determining what the future of functional programming will be. I love this quote from Frantz Fanon, the Martinican philosopher. He says, "I do not have the duty to be this or that. I am not a prisoner of history." I think for us that's true. We're not a prisoner of the history of functional programming. We're not bound to what the history of functional programming was. We can indeed change our approach to the future. And I think that if we return to the story of that boot camp student, I hope that in the sort of future of functional programming, that a decade from now, my answer to that boot camp student will be, you should learn Elixir because it will get you a job. Even more so, I hope and I pray even that developers like my niece do not even have to ask that question, right? She's 10. And I hope that when she's 20 and she's going out to look for a job, she doesn't have to ask why functional programming matters. It's self-evident, right? Because the top languages, right, on that list are functional programming languages, or it's so popular that her professors have to teach it. I think this will take significant work, both as language practitioners, as library builders, but also as evangelists. However, I think it is work that we as a community can do, and I really look forward to seeing what the future of Elixir looks like. Thank you.
Lots of excellent points made. Questions?
I thought that really was excellent. I really appreciate it. And I think it's really important to have the historical perspective. And I think even more than just knowing it exists, going back and researching some of those languages and actually using them is a fantastic way of building current skills as well. And I think your story of the boot camp attendee was germane, but I think it's germane in a more general way. And that is, I think every single one of the people in this room, and me included, are boot camp attendees, right? And I think we all need to be asking that question every day. One of the problems that a lot of languages have, like, for example, Java, is people tend to define themselves as, I'm a Java programmer, And I would hate for us to become, I'm an Elixir programmer, right? Ultimately, it's what the language can do for you. And if you can find ways of expressing to people the ways in which this makes you better, then it's a natural that they should want to do it. If you can't find ways of expressing that, then maybe you should be moving on.
Touche. This question back there.
So another pattern that you see is the new ideas working their way into older languages, right? They almost always, successful languages become multi-paradigm. You alluded to that with JavaScript. So in the case of your niece, what keeps us from her ending up doing functional programming in C++ in a decade?
Well,
I'm not making a statement on whether that's good or bad. I'm just saying, as opposed to the Beam, Elixir, Erlang, that type of environment or ecosystem.
no, it's interesting. There's a great talk by David Turner, the founder of Sassel, where he makes this sort of pseudo argument that Fortran is functional, right? It's this very interesting academic perspective on what functional programming means. I don't see a reason why not, right? I think if we do the work necessary to go out and spread the word about functional programming outside the context of functional programming communities, I think what we may find is that people decide, well, I love Java, but I'm only going to write Java in a functional style, right? I did this previously at my last job where I taught a bunch of classes to C# developers on functional programming, and we started seeing PRs left and right where people were using pure functions in C#, right? And they refused to program in sort of imperative style. So I think what it means is that, yes, Elixir will develop, yes, languages that are functional by nature will develop, but what we may see is that these traditionally imperative languages that already do support functional programming idioms might sort of become more functional by nature. I think Java has already seen this happen with things like the popularization of lambdas, and I think it may happen even more. And if my niece lives in that world, it's not a bad world to live in, right, where she can be a C++ developer and do embedded stuff and still get to live some of the functional idioms that I enjoy.
I guess to ask the opposite version of that question, as we're bringing people into the community, how do we help newcomers stop writing object-oriented code?
Wow, it's an interesting question. I think there are a couple of 2 points. I think the first is the answer to them doing that is to say, okay, I get it. This is hard. This is different. But I think the second is to do the historical work of saying, well, let me explain to you what functional programming is, right? Because I think starting with, well, you're writing bad Elixir, right? Slap on the finger, is a very disheartening approach, and one that, as a teacher, isn't really useful, right? Because you haven't taught the person from the ground up, here's what functional programming is, and here's how you should build a functional program. So I think the way to stop folks from doing that is to maybe teach them some basic functional programming, maybe not in Elixir, right? Maybe in a different language. So when they come back to it, right, they're like, oh, okay, I get why we are trying to write pure functions. Because I think otherwise, when you start with you're writing Elixir wrong, it actually hurts people's, not feelings, but their ability to learn, right, what true functional programming is. So I would say maybe do the corollary. As opposed to having them write Elixir, if you see that their Elixir is really, really bad, maybe take them a step back from it. That way they can understand the language better. I just think pedagogy is really important. Teaching people how to learn is much more important than actually hurting them for doing something wrong. Oh, hello.
Hello? Great talk. You brought up Michel Foucault, and he's a post-structuralist, and he kind of says that things are just all arbitrary, basically. So, for instance, madness is arbitrary, how we define it. And so when you were looking through the history of computer programming languages, did you find that things are arbitrary, like what we believe within the functional programming community, what we hold as the proper way to do things? Do you think it's arbitrary, or do you think it's the right way, TM?
So,
Sorry for the hard question.
Yeah, that was a hard one. That was a hard one. Jeez. How do I answer this without making enemies? I mean, here's the thing. There are multiple ways to do things, right? You can build great software in an imperative style. You can build it in a functional style. Most of the things we use today, like that make our lives happen, like the power coming on and off, are built in imperative languages, so on and so forth. So I think functional programming has great ideas and great sort of research on building great computer programs. However, I think that it is not a fault of functional programming that we haven't seen adoption. I think it's our own tendencies as individuals to take things that are kind of arbitrary, like what language you use to build something, and then say, well, like, this is the best way to build something, and if you aren't building it this way, you're not smart, right? I think that's a tendency we have, not something that's built into the language. I would say functional programming is like one of the most underappreciated parts of programming today, and it is our work to make that true. It is our work to make it non-arbitrary, right? So yeah.
Thank you. Thank you for the talk. You seem to be asking for a call to action, right? That we actually get out on the street and do something. And so I was wondering if you could give us an example from your Elixir meetup, because honestly, that's one thing that comes to mind. I don't personally have a PR budget, so but I could make a difference in the community through a meetup. Can you share a story or an anecdote of a way you were able to reach someone new or a group that was new, an adopter?
That's a great question. One of the ones that kind of stands out off the top of my head is that in Atlanta, like JavaScript is really popular, as it is everywhere. So we have a really big React meetup. It's about 70 people every time show up to this thing. I've spoken there twice, and every time half my talk is React, the other half is Elixir. And for some reason, they keep inviting me back, and I'm just like, we're gonna keep this train going. And the guy who runs it's my friend, so that's part of it is like we know each other. But I'll give a talk, and I'll give a 30-minute session on here's an introduction to Elixir. And by the time people leave, they're like, oh, wow, I came here to learn React, but now I know a little bit more React, but a lot more Elixir. And I've seen 2 or 3 folks from there. One just got a job actually. From seeing me speak at that meetup, he started coming to my meetup to learn Elixir, and now he just got a job as an Elixir developer after finishing boot camp, right? So I think that's one story where you go to meetups that aren't your own. You sort of infiltrate these meetups, maybe you kind of sneak in by pretending that you're one of them, and then you just you finesse a situation in which people are now sort of more interested in the language because you've done the work of bringing it to them rather than expecting them to come to you. Yeah. Go ahead.
Everybody knows that I'm a beginner on Elixir, so I'll just talk why I like Elixir. And one of the things that you said is about marketing, right? Why did I fall in love with Elixir as soon as I saw it? It's because it's the language built for the cloud. Because I don't know other language that it takes you about 10 minutes to be running in 2 different computers and talking to each other trivially. We tried with Rails, and we're suffering for it. That was just a comment.
Thank you. One sort of quip I'll make is to your point about sort of Elixir being built for the cloud is I think there's even more work to be done there, right? There's all this fancy terminology around cloud native that's happening now, and as a purist, I'm like, it's very interesting, right? We've always been cloud native. But I think that's work we have to do, right? We have to go into these conversations about cloud native at our companies or wherever these conversations are happening and say, well, hey, cloud native, we've always been doing that, right? We've always been interested in distributed systems. This isn't something magical that we've invented in the last 5 years, right?
Seems like the entire conference has kind of trended towards that direction. Chris's talk and all the distributed systems talk yesterday. Elixir's great. It's got great distributed tooling. We need better. We need more.
Yeah.
I'm interested, I guess, mostly in, because you sort of frame all of this as a genealogy, where languages that have taken on functional aspects fall into this. Many languages these days, many of them JavaScript, and you've touched on it in that respect in React and in some of these. How does that play in, and is that something that you see we can leverage in the future as well? You didn't touch on it explicitly, I guess, is the only reason why I asked.
Yeah, I think a couple of sort of points on that. I think one, the sort of popularization of functional programming ideas outside of purely functional languages, or even strongly functional languages, is an opportunity for us, right? Because we can go into companies where people know React but don't understand what a pure function is. We can go in there and teach them Elixir because they already know React. And this is what I've seen in my experience, right? But I think it also means that we can go into companies where folks might not want to use Elixir because it's new or it's different than Java, but they already understand lambdas, right? So you can explain things to people in their own context in a way that helps them adopt the language easier. So I think for us it means language adoption is much easier than we need it to be, but the hard work is still going to those places and having those conversations, right? I think we're probably up.
I've already gone, so if someone else has got it, then.
Regarding your note on evangelism, as someone who's been doing evangelism for the 5-6 years, my observation is always key in on the eureka moment. What caused you to move from the language you're using into Elixir, right? And keying on that and spreading that is a good way to spread evangelism. The second thing is tooling and documentation, because once you get them in, you still need to keep them. So those are some points that I thought might be worth talking about or discussing as a community. So, speaking as someone who's not in the Elixir community, of course. So.
Thank you.